We are now at question 6 of this CXC CSEC January 2014 General Paper 2 exam video solution. And in this question 6, we are given this diagram, and we are told that in this diagram we have a pair of parallel lines AQB, that's this one, and CRPD, that's this second one. So these are two parallel lines, and PQ is equal to PR. So PQ here is equal to PR, and so this is an isosceles triangle. And we're also told that the angle QPR is 28 degrees, that's the angle right here, and that the line MQRN is a transversal. MQRN is a transversal, and the transversal is simply the line that crosses the parallel lines. And in the diagram, we are given the angles X, Y, and Z. X degrees, Y degrees, and Z degrees. And we'll be required to find the value for X, Y, and Z. But before we proceed, we want to use the information we have about this isosceles triangle. And this is it. Triangle PQR is an isosceles triangle because, as I've said, this length is equal to this length, and therefore these two base angles are equal. And we can show that the angle PQR is equal to angle PRQ. That's this angle right here is equal to this angle right here. These would be the two base angles of this isosceles triangle because this length is equal to this length. And so we can call those two angles theta and show it on the diagram. And now total angles in this triangle is equal to 180 degrees, and we can use that as the basis to find the angle theta. And this is it. Total angles in the triangle is 180 degrees, and therefore 28 degrees plus 2 theta is equal to 180 degrees. We can now divide through by 2 to simplify this equation. When we do that, we divide each term by 2. So we divide 28 by 2, we get 14 degrees here. 2 theta divided by 2 gives us theta, and 180 degrees divided by 2 gives us 90 degrees. And now theta is obtained simply by subtracting 14 degrees. And this is it. Theta is 90 degrees minus 14 degrees. And so theta is 76 degrees. And we can now move to the questions. The first part wants us to calculate the value of x. And to calculate the value of x, we would need to calculate this angle here. And once we have this angle, we would know the value of x. Now if we observe, we see that this line is parallel to this line, and this line crosses those two parallel lines. And so we have alternate angles here, or what we call z angles here. This is our z right here. And so this angle x degrees is equal to 28 degrees. And so we can show that x degrees is equal to 28 degrees because alternate angles or z angles are equal. And since x degrees is equal to 28 degrees, it means that the value of x is 28. And so that's the answer. X is 28. Let's move down now to part 2. Now what we have so far is that theta is 76 degrees and that x is 28. And the second part now wants us to find the value of y. And to find the value of y, we need to find this angle first. Now what we have here now is a straight line, and we know that total angles on a straight line is 180 degrees. And therefore theta plus y degrees will be equal to 180 degrees, and that's the basis on which we can find the value of y. So let's show that, and this is it. Theta plus y degrees is equal to 180 degrees because the total angles on this straight line right here will be 180 degrees. And since we know theta is 76 degrees, then we can put that in this formula here. And when we transpose to make y the subject by subtracting 76 degrees from both sides, we end up with y being equal to 180 degrees minus 76 degrees. And that gives us y degrees equals 104 degrees. And therefore, the value of y is 104. And that's the answer for that part. Let's move down to part 3. Now what we have so far is that theta is 76 degrees, x is 28, and y is 104. And now we are asked to find the value of z. Now I want you to observe that we have opposite angles here. The angle z theta here will be equal to the total angle across here, which will be theta and x degrees, because opposite angles are equal, and we can show that z degrees will be equal to theta plus x degrees, and this is because opposite angles are equal. And since we know theta and we also know x, we can proceed to calculate the value of z, and this is it. Z degrees will be equal to 76 degrees plus 28 degrees. And so when we do that calculation, we get z degrees equals 104 degrees. And so the value of z is 104. And that's the answer for that part. Z is 104. Let's move down now to part B. Now part B gives us this diagram. It consists of two triangles. It's a graph of two triangles, triangle JKL and triangle J prime K prime L prime. And we are told that J prime K prime L prime is the image of a transformation on triangle JKL. And the first part of this question wants us to state the coordinates of the point J. That's this point here. Now clearly the coordinates of the point J would be negative 4, 1, and so we can write that coordinates of point J is simply negative 4, 1. Part 2 wants us to state the length of the line K prime L prime on the image. That's this line. K prime L prime clearly is 2 units long, and so we can write that answer. K prime L prime is 2 units long. Part 3 now is asking us to describe the transformation that maps triangle JKL onto triangle J prime K prime L prime. That is, we are required to identify and describe the transformation that maps this triangle onto this triangle. Now initially we might want to believe that this is a rotation, but before we can conclude that is a rotation, we must check the orientation. And so if we look at the orientation of the object, JKL around the object is anti-clockwise, but if we look at the image, JKL on the image is clockwise, and so the orientation is reversed. And because the orientation is reversed, we know that the transformation is not a rotation. In fact, orientation is reversed after a transformation when that transformation is a reflection in a line, and so we know that the transformation that maps this triangle onto this triangle is a reflection in a line. We also know that a reflection in a line will be such that object distance will be equal to image distance from the line, and therefore the mirror line will pass through the midpoint between J and J prime, will also pass through the midpoint between K and K prime, and will pass through the midpoint between L and L prime, because reflection is such that image distance is equal to object distance from the mirror line. So let's show that, and this is it. The mirror line will pass through this point, will pass through this point, and will pass through this point, because the mirror line will be positioned such that the object distance from the mirror line will be equal to the image distance from the mirror line. And therefore the mirror line is the line that passes through these points down here, and so we can show that. And this mirror line clearly is the line y equals x, because it passes through the origin, it passes through the point 1, 1, also passes through the point 2, 2, and so this mirror line is the line y equals x. And therefore we can describe the transformation that maps the triangle JKL onto J prime K prime L prime as a reflection in the line y equals x. And that's the answer for that part of the question. Part 4 now wants us to write the coordinates of J double prime, K double prime, and L double prime after a translation of 5, negative 3 on the triangle JKL. Now firstly, we must identify the coordinates of the triangle JKL, and we have it here. J, as we said before, had coordinates negative 4, 1. That's right here. K has coordinates negative 1, 1, and this is it. K has coordinates negative 1, 1, and L has coordinates negative 1, 3, and that's it. L has coordinates negative 1, 3, and we want to see what the image of these points will be after a translation given by 5, negative 3. Now the translation 5, negative 3 will move each point 5 units to the right and 3 units downward. That's what this translation will do. It will move each point 5 units to the right and 3 units downwards. But let's construct the translation on this diagram. So let's start with the point J. J will move 5 units to the right and 3 units downwards, and this is it. That's 5 units to the right and 3 units downwards, and so this is where J double prime will be. This is it. 1, 2, 3, 4, 5 units to the right, 1, 2, 3 units downwards, and so J double prime will be located right here at this point. That's 1, negative 2. The point K also will move 5 units to the right and 3 units downwards, and this is it. 5 units to the right and 3 units downwards. That's 1, 2, 3, 4, 5 units to the right and 1, 2, 3 units downwards. So this is where K double prime would be. The coordinates of K double prime will be 4, negative 2. And then for the point L will also move 5 units to the right and 3 units downward under this translation. And let's show that. That's 5 units to the right and 3 units downwards. 1, 2, 3, 4, 5 units to the right. 1, 2, 3 units downwards. And so the point L double prime will be located right here at the point 4, 0. And so since we have those points in place, we can go ahead and show that triangle. And that is the image triangle after a translation of JKL by translation 5, negative 3. And so we can put the values here for the coordinates. So J double prime is 1, negative 2, K double prime is 4, negative 2, and L double prime is 4, 0. We could have also calculated these coordinates by adding these values to the coordinates of the original points. So for example, we could say the coordinate negative 4 plus 5 would give us 1. And we could say 1 minus 3 gives us negative 2. So we could add the values in the translation matrix to the coordinates of the point. And again, for the point K, it would be negative 1 plus 5 would be equal to 4, and 1 minus 3 would be equal to negative 2. And that's how we would do the translation for the point K if we were to do it by calculation. For the point L, it would be negative 1 plus 5 equals 4, and 3 minus 3 equals 0. And so we could have gotten those coordinates by calculation using the values in the translation matrix. In any case, these are the coordinates of the point J double prime, K double prime, L double prime. And that's the answer for question 6b, and that's the end of question 6. And we'll do question 7 in the next video. See you then.